Let's implement our queue data structure. The very first thing we're going to do is the nice and simple peek, which simply tells us what is the very first item in our queue. So this dot first is what we want to peek into. If I run my queue dot peek, I should get null because, well, there's absolutely nothing in our queue. What about onQueue or enqueue? I'm not sure how to pronounce that. Let's go with enqueue. In there, we want to add to our waitlist. Again, similar to what we did with stacks, we're going to create a new node. And we're going to instantiate this new node with a value. Remember, we have the class here. And this value is going to get added to a node that has this dot value and this dot next. We then want to check and say, hey, if this dot length is equal to 0, that means there is nothing in our queue, then simply say this dot first is going to equal the new node. And same with this dot last, because there's only one node in our list. This is very similar to what we implemented in the stack. Otherwise, we can say that this dot last dot next, so that is whatever is at the very last of the line, and whatever the next value is, which initially, whatever is last is pointing to null, but we want to update that to say, this time, instead of pointing to null, point the new node as the last in line. And we want to update this dot last to now equal the new node. So that whatever was last in line is now pointing to the new node, and the new node is now last, which is going to make sure that this dot last points to null. Finally, we can't forget to increase the length by 1. And then we can just simply return this, our data structure. So let's have a look. We want to create this line, queue. So all we're going to do is say we want to onQueue joy. If I click run, first node, I get joy with next null, and last node is, again, joy with next null and length of 1. So far, so good. What if Matt comes and gets in line as well? If we add Matt, we now have first node that is joy and last node that is Matt. And you can see here that the first node of joy is pointing to the next node that is Matt. All right, let's add a few more. We'll add Pavel, who just got in line, and then finally Samir, a little bit late, but he got in line as well. If I click run, perfect. Our last node is Samir. We have a length of 4, and we have the joy node, which is the very first item in our queue. Now, let's say we open the door and we start letting people in. We want to dequeue this list and go from the very first in, first out, all the way till the end. Once again, it's very similar to a stack, except that we grab the node from the beginning instead of at the end. So we're first going to say, if there's no this dot first, if there's no first item, we can also check the length here if we want. So the list is empty. In that case, just return null. And by list, I mean the queue. If the queue is empty, then return null. We also want to check if this is the last node in our queue. So we can do something similar with what we did in stacks. We can say if this dot first equals this dot last. Again, we can just check length here as well if we want. But for now, this should be fine. If that's the case, I want this dot last to equal null. Remember, we make sure that now last points to null. And regardless, as soon as we dequeue, we want to say this dot first equals this dot first dot next. That is whoever is first now, because we're going to remove joy. We want who's ever after joy, that is Matt, to be in first priority now. And then we simply say this dot length minus minus to decrease the length, and we can return this. If I run this, well, it's the same thing because we haven't run it here. So let's go ahead and do that. Let's first of all run my queue.peek to see who should be coming out of the queue, and that is joy. So if I do my q.dq and I click run, we see that now Matt is first in line, Joy has been removed, and length is of 3. And one thing to point out here, once we run dq here, we've completely lost the Joy node from our memory because we have no more reference to it. Nothing is pointing to that memory space. And JavaScript, the way it works is going to garbage collect and remove Joy. If we wanted to hold a pointer to Joy, then we could say const holding pointer and say this dot first, so that before we update whoever is first, we can reference it with this variable so that we could potentially, if we still want to use Joy, for example, in a waiting list app, maybe we still want to do something to the user, we can do this and still have access to the Joy node. All right, let's finish this queue. Let's dequeue everybody from here. If I do dequeue, and let's return this back to this so we see what's happening. If I run, now Pavel is first in line and Samir is last in line. If I click, or if I had dequeue again, and I click run, Samir is the last person on the list, but then we can finally let him in as well. There we go. Now we have an empty queue, and we've just implemented our own queue data structure. Well done. Hope you had fun. I'll see you in the next video. Bye-bye.